Bem-vindos ao IoT Weekend. Meu nome é Valter Minute, and thanks to my colleagues from the Tordex office in São Paulo that teach me a little bit of Brazilian Portuguese, but just a little bit, so the rest of this video is going to be in English. In this session, I will try to describe and to talk about some of the issues and challenges that you can face when you want to build a product that involves hardware, software, and maybe even some internet-based services. I have around 20 years of experience in this field, and I already made quite a good number of mistakes, so maybe talking about them can help others avoid them in the future. Did you ever back a project on Kickstarter that was promising a very interesting device at a very low price? Did it deliver what you expected and what you actually paid for? It seems that around 90% of all Kickstarter projects that reach full funding then fail to deliver. This means around 1 in 10 projects. Is that due just to scams or to people disappearing with the money? There were some cases of people doing that in the past, but it seems that they are a very small percentage. And if you search for the most spectacular failure on crowdfunding projects, you will discover that many of them are devices, or even better, what their marketing was proposing as IoT devices. IoT is not just a marketing buzzword. We have already a lot of connected devices around us, and some of them are quite successful. Let's think, for example, about the Nest thermostat. First of all, for sure, it was a big success for the inventors, because their company has been acquired by Google for, I think, $3.2 billion. But the Nest was a very good product. It was very innovative, it was connected, and by being connected, it was providing very useful features. For example, it can access weather forecasts, or you can control it from your browser or from a phone, just using an application. Those are interesting features, and for sure the Nest is a very good product. So why we have other products that really look interesting, that we are even able to see in some demonstration videos, that then fail so badly? That's because they are really not products, but they are just prototypes. And in this session we will try to understand a bit better the difference between a prototype and a product. But before we start discussing about how to move a prototype to a product, let's see another example. This article appeared on the social media accounts of many of my geek friends just a few months ago. And the title, it's quite interesting. We compare an $86 million system with just 57 lines of code. I would have been surprised by such a statement, even if it was coming from Chuck Norris. And we're talking about the guy who counted to infinite. The article describes how the author implemented a license plate recognition system using the Raspberry Pi and some open source libraries. The system can recognize the license plate and check if the car has been stolen or anything else. So he really implemented a multi-million-dollar system using just a small amount of source code? No, as is honestly admitting in the article, what he made is really not the full system. It's just a prototype. Maybe even a step before a prototype is just a proof of concept. The final product, the 86 million project, it's made of devices that are mounted inside police cars and should recognize license plate when driving around in the city, and it's supposed to do this in a reliable way. This is what you expect from a final product. And even if this price seems to be huge, I can tell you that it's not so uncommon when we are talking about moving from a prototype to a product. Even if we know that when taxpayer money is involved, probably prices tend to rise a little bit. I haven't done it, I know about this quite well. But difference between a prototype and the product, even in terms of money, it's quite big. But I think that the article raises another interesting point. Today, we have the tools and technologies to quickly build any kind of prototype. When I started working on embedded devices quite some time ago, an evaluation board that you should use just to build a prototype connecting some sensors and other things to a processor was costing more than my car. I have to admit that I was not used to drive fancy cars, but anyway, it's quite a good amount of money. And it's the kind of money only a company can invest. It's not the kind of money that a private person can spend for this. At that time, getting information about this kind of technologies and trying to discuss with other people working on this kind of platforms was quite complicated. We are talking about the pre-internet era. Today, we have the Arduino and the Raspberry Pi, and with just a few dollars, we can create something. We can connect sensors, we can read data from the environment, we can connect to services and everything. And those platforms are really available for anyone who can just spend a little bit of money and is willing to spend some time experimenting. And today, it's also very easy to exchange information with other people, to get involved into community of developers or just passionate people with the same interests. This is what some people call the makers' revolution. And I think that makers can really bring some new perspective, new ideas inside a company or inside any kind of workplace. For example, you can think about the Wright brothers. They were professionals in building and repairing bicycles. But as makers, protected only by leather helmets and fancy mustache, they started experimenting, and at the end they managed to build the first flying plane. Probably at the same time, the best professionals were busy inventing faster ships and trains. I consider myself a maker. I have Arduinos, Raspberry Pis, lots of other gadgets. I even own a 3D printer. I also managed to write a book about the Raspberry Pi, but it's in Italian, so buy it only if you speak my language. On the other side, I make software for embedded devices as my main job, so I should also consider myself a professional. I know many makers that are big professionals too. Sometimes they are not professional software developers or hardware designers. They can be professional biologists that use this kind of tools to collect information from the environment. Or they can be teachers that use technology just to get their pupils more involved in the subject they teach. Makers can definitely innovate, can bring a fresh perspective, new ideas, and develop some interesting things. But do we need professionals anymore? First of all, I think that professional is the most abused adjective ever, as this role of professional toilet paper proves. But talking about professional people, I think that you may need the help of some professionals to turn your prototype into products. At least because professionals already made a lot of mistakes that makers have still to make. Or, if you prefer, professionals are paid to deal with the boring details that are involved into moving a great prototype into a great product. So, what's the difference between a prototype and a product? If we want to use a poetic definition, we can say that a prototype it's an idea trying to become a product.
Prototypes are our little pets. We keep them protected, we play with them, we want to see them growing into something better. But not all prototypes will actually evolve into products. And when they do, probably the final product is going to be quite different from the initial prototype.
Products are usually more complex, but on the other side, they are also more valuable. And this is required because, the world is a tough place.
There are many things you should consider when you are moving from a prototype to a product, and in the rest of this presentation, I will try to highlight some. When we make a prototype, we make it for ourselves, and just because we think it's a good idea. When we want to move it to a final product, we need to find a market for it. And there are two markets that are quite different. One is the consumer market, and the other one is the industrial market. Just to show the differences, I will take two sample products. One is a smartphone, and the other one is a dump truck. As you can see, they are quite different.
When you need to build a device for the consumer market, you need to care about design, about feature, about aesthetics, and you should also try to build a device that is very cheap to manufacture, because of course you are planning to sell a very high number of those devices, 100,000, millions of them, and so saving even a small amount of money on production for a single piece at the end is going to be a very good thing for the project, because you can multiply the saving for the number of devices. You want to make a very cool device, a device that people like, and a device that is reliable enough to stay on the market, at least for the warranty period, but hopefully a bit longer to keep a good reputation for your brand.
On the other side, usually industrial products are built in small numbers. Sometimes they are very customized for a very specific kind of activity, and it's not rare that you have even just a single piece. People buying industrial devices use them for their work, so they expect to make money from those devices. And if the device is not working, if the system is not working, it can prevent those people from getting money and generating damage. So reliability is the most critical thing in the industrial market. And I can tell you, even if it's not looking so cool and geeky, there is a lot of technology even inside the dump truck. Of course, there are products and devices that can be something in between consumer and industrial markets, so they should be nice and provide lots of features, and on the other side, they have to be very valuable. And of course, this does not mean that the smartphone should not be reliable or that the dump truck should be ugly. Both industrial and consumer devices will face challenges from the environment. Environment is a very generic definition, and your devices may work in very different conditions. We may have some devices work inside an office, maybe even air conditioning, and we have other devices exposed to more extreme conditions.
For example, think about a device that should be used inside a car. Cars are working in a very extreme range of different conditions, from the under zero temperatures of Canada and Scandinavia to the 70 and more Celsius degrees of parking lots in Brazil, Dubai, or these kind of places.
Not all electronic components are designed to work on all these range of temperatures. For example, probably the battery of your cell phone will very quickly discharge at very low temperatures, or the processor of your PC working at 70 degrees Celsius environment temperature will shut down because it has reached maximum operating temperature.
So what you have to do if your device is going to be used in different environments is to check the specification of your components and design it for the worst case.
Other things like electromagnetic interferences, humidity, dust, vibrations can influence the operativity of your system. And don't forget humans. And it's important to take care of those factors when you design your system, not just when you select your components.
For example, in some makers challenges, I have seen some home automation system using the I2C protocol.
I2C is a very simple protocol from the hardware and software point of view. It's easy to implement, but it comes with some limitations.
It has been designed to transfer data over tracks on a PCB. It can work over wires, but it has quite some limitations. Limitation in terms of speed and limitation in terms of maximum length of the cables.
You can overcome the hardware issues using some hardware adapters, but the software protocol, it's really not designed to work on unreliable connections. So, for example, it has no checksum to validate the data it's receiving. So your I2C device can receive a completely bogus command and probably try to actually do what the command requires. And if you don't know about this, you can start with a prototype on your desk, and this is going to work. It will work even if you build a small doll house to emulate a real house. But when you move to a real house, it will not work anymore. And this will require a redesign.
This means that if you use I2C for your prototype, you will probably need to redesign your system using a different protocol for your product. And this may require quite some effort.
In this case, knowing some theory probably leads to better results. There is also a TV series about that.
Mistakes in software or bugs can be bad, but mistakes in hardware design are at least bad, when they are not very bad or horrible.
Redesigning your hardware can require a lot of time and resources, and rebuilding your prototype can also require quite some time or money, or both.
Since we are dealing with a physical thing, when we make a mistake in designing the hardware, we may have to change the layout or change some components, and then we have to wait until new devices are built and produced.
This is when some help from a professional may really pay back.
To reduce the chances of mistakes in hardware design, you can try to reduce the complexity and the number of components in your system.
One thing you can do to simplify your hardware design is to use a modular approach.
For example, I work for a company, Tordex, that makes computer modules. Just a single module can replace your processor, your memory, your storage, and reduce greatly the complexity and the number of components involved in your design. This is a tool that one of our partners, Gamsix, has made. This tool is named Geppetto, and it allows you to design a system using high-level building blocks. For example, I can take one of our modules, I can select an Ethernet connector, and I connect it to the module. Then, if I want something a bit more old-fashioned, I can select, for example, an RS-232 interface and connect it to one of the serial interfaces available on our modules, and so on. I can select different kind of connectors, power supplies, and interfaces like audio, etc. When I finish defining the components of my system and how I connect them together, I can even estimate the price for my final device. And I can even have an estimated delivery date for production. Of course, this comes for an additional price overhead, but at the end, it simplifies the hardware design phase and so can avoid expensive mistakes. So it can be cheaper in the long term.
And of course, what I said about the electronics applies also to mechanical elements of your device. What is important to remember is that it is not possible to patch hardware with an over-the-air update. Another challenge is actually move to production. The day you decide to assemble your device, all the components should be there, even the most insignificant ones. A delay in getting even the most inexpensive and, let's say, stupid component can lead to a massive delay in your production. And if you plan to save costs on production, like it often happens in consumer market, you will have to care about a lot of details, like where do you place your connectors, how much manual effort is required to assemble, and so on. Design can be more exciting. You are building things, discovering new things. Production can look a bit more boring, but I can tell you that the effort behind it, it's really, really big. It's a matter of fixing many small or big problems and taking care of lots of details. And we can see some real-world samples of companies that are very good in designing new products, but they have quite some issues in delivering them to their customers. Production may be boring, but it's what makes a company run in the long term. Unless your plan is to sell your company to Google or just to disappear with the money you collected on Kickstarter, you probably will want to run your company for many years. And mostly if you are targeting industrial market, this can also mean how to be able to produce your products in the long term. It will mean that one customer can come back and ask for a product that you have been selling for the previous 5 or 10 years. And this is what's usually customer expected in the industrial world. Components that are designed for the consumer market usually have a very short lifetime. In consumer market, we have new products every 1 or 2 years. So when you design your system, you should be careful about choosing components that have a long lifetime. And if some of the, let's say, less important components will no longer be available, you should try to find suitable replacement, keeping the functions of your products exactly the same. It's more or less the same thing also on the software side. You probably want to use some mature technologies, some things that are going to be here to stay, so you don't risk to have to re-implement some critical part of your system later on. For a prototype, you can focus on short term, doing a brilliant demonstration. For a product, you have to think about the long term. Another important point is certifications. Before you start selling your product, you probably have to check that it's not generating interferences, that it can survive a certain level of interferences, and that it can operate in a secure way. The kind of certifications you may need to pass depend on your target market and also on the local rules of the different countries where you plan to sell your product. But it's important to know what are those requirements in advance, because failing to meet those requirements may actually prevent you from reaching those markets. And of course, in some fields like automotive or medical devices, the requirements about certification are more strict, because failure for those devices can lead to injuries to people or even more. Not getting a certification may prevent you from selling your device. So the important point here is learn the rules before you start playing. There is nothing bad in showing around the prototype. But on the other side, I think you should be clear about the state of your project. If you state clearly that this is a prototype, that's perfectly fine and honest. On the other side, if you are not honest about the status of your current device with your potential investors, with your boss, with your potential customers, probably they are going to raise their expectation about delivery time and so on, and they're going to be disappointed. It's not impossible to move from prototype to product. We have many successful samples around us, but we should be careful, we should plan in advance, we should try to avoid potential mistakes and issues. I hope that this session is useful for the people who are involved in the design of the device or who plan to do that. It's not simple or even possible to give advice that applies to each and every project. I try to give you some generic advice, hoping that this can be useful. Of course, I don't want to scare you. It's absolutely possible to successfully move from prototype to product. We have lots of devices around us proving that. But planning in advance and knowing a bit about the potential issues definitely is a good thing to do if you want to be prepared. Know the expectation of your target market. Design for the worst case. Plan for the long term. Don't break the rules. I hope you enjoyed this session, and after you have seen the video during the IoT weekend event, we are going to have some time for questions and answers. Otherwise, you can contact me using Twitter or my email. Thank you for your time. Keep playing.